Go ahead and get started here. So my name's Matthew Cooper. I'm from NC State University. My colleagues Barra Cola from Georgia Tech, Penny Hirsch from Northwestern, Mani Mina from Iowa State, Erican Shaker from Cal Davis, Stephanie Clausen from Colorado School of Mines, and Ed Berger from Purdue. The name of our team is Reflection 2 Concepts, or R2C. So we're going to start off here with an elevator pitch, a 1-minute elevator pitch. So we felt that pedagogical research and our teaching experience show that many engineering students often rely either on rote use of equations or strongly held misconceptions in order to solve problems. And scholars have similarly shown that reflection can be an essential, adaptable method in order to engage students in exploring what they actually know and encourage deeper learning. So our group is interested in developing reflective tools and strategies to identify, assess, and challenge student conceptual understanding. And our goal is to provide reflective tools to transform engineering education culture, produce more thoughtful engineers, improve their lifelong learning, and thus strengthen American innovation. And the idea here with the fishing is we're trying to teach a man to fish, show them how to challenge their own misconceptions about what's going on in the world around them, so that as they grow older, they might feel the need to challenge those misconceptions themselves and learn more about what's going on around them. So in order to illustrate this, we've got a brief 2-act play that we'll be putting on. So this is going to take place in a bar. So we open on this bar where engineering students are relaxing after a long day with their liberal arts friends. 2 people, one an engineer, played by Erican, and another a humanities major, played by Penny, are eating hot macaroni and cheese.
Oh, this is so hot. I'm going to blow on it to cool it off.
Oh no, here comes Miss Concepto, who thinks reflection is a waste of time.
Get your equations, heat transfer coefficient calculated.
Okay, stop. Let me just calculate the C's. It may warm up when you blow on it. 1 second.
Here comes our superhero, Reflecto Concepto. Whose goal is to promote reflection, to correct and deepen understanding.
Time to reflect. Engineer, this is a simple, intuitive problem. You don't need that calculator in your equations. Think about it. What do you think?
Actually, I think I have a misconception. This is just forced convection versus convection. You can blow on it, it's safe. I think it would go.
Now you're reflecting.
It looks like another engineering friend has arrived to the bar, and the pitcher of beer that they ordered is arriving too.
Oh, hey, Stephanie, how are you?
How's it
Good to see you.
going?
Pretty good.
Oh, beer's here. Here's your pitcher of beer. I've got a cup of ice that I'm going to put in there to keep it cool without watering down the beer when the ice melts.
Oh, good. Good idea.
Yeah, let it cool. You don't need anything. You're an engineer. Spit it out. You know the answer.
Okay, I think that's probably a good idea.
Yeah, makes sense.
Reflecto concepto. Hold up. The last problem you had, engineer, was a simple, intuitive one. But this one seems like it could be more complex. You need to think about this. Are there other parameters that you must consider? And oftentimes, teamwork is the best way to reflect.
Yeah, Erican, look, when waiter Ed put the cup into the beer, it increased the surface area of it. It's not actually clear to me what's going to happen. This might be a place when we want to use some mathematical analysis.
All right, let's think about it. So the surface area goes up. There's like some
Temperature,
cooling.
material.
Wow, it's interesting. It actually warms up. It doesn't cool it down.
Oh, no kidding.
Well, I guess let's not leave any tip.
Now you're Engineer, you have become the ideal student.
Thank you, Perfecto, Concepto, Reflecto. Now I know how to explore my conceptions. Thank you.
So now we have arrived at Act 2. Time has passed, and our gang goes back to the bar to celebrate the end of the semester, But another common misconception arises.
Man, I am so glad Reflecto Concepto taught us to use reflection to address our own conceptual misunderstandings this semester. I guess that's why we can spend so much time in this bar.
I know.
Well, if you guys are so smart as engineers, maybe you can tell me why is this bar so cold? This bar surface, when I put my hand on this napkin, I mean, why are they different temperatures?
Yeah. Use that, yeah.
Actually, you know what? Let's reflect on it. Oh, I mean, it's clear. They are the same temperature. It's just that the thermal conductivity of the towel is so much less than the stable. That's why it feels cold.
Oh, thanks for explaining that.
Sure, no problem.
And Reflecto Concepto has saved another engineering student from a lifetime of not questioning their own misconceptions.
Thank you.
Reflecto perfecto.
And scene.
So to recap, or reflect, if you will, on that Oscar-winning performance, we are interested in how we can use reflection to enable conceptual change and to lead to deeper conceptual understanding. And reflection can take many forms. So sometimes it's a verbal or a written reflective piece. It might be a poem or a song. Or there might be times when it does actually involve going back to the math and trying to tie that to the concept that you're trying to understand further. So with that, any questions?